Hey guys, tonight we are diving into something truly weird and wonderful. Quantum entanglement, connecting you perhaps to another version of yourself somewhere across the cosmos. Imagine that for a second. Maybe that other you is also listening to Sleepcovery right now, though statistically they're probably eating snacks and binge-watching Netflix instead. And honestly, can you blame them? Quantum physics is fascinating, but a bit intimidating. In fact, you might not survive even the first day of a real quantum leap. But thankfully, tonight, we're just imagining. So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here on Sleepcovery. And hey, why not tell me your city and what time it is right now in the comments below? I'd love to see where everyone's tuning in from. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. Quantum entanglement. You've probably heard the name thrown around a lot, but if you're like most people, your first reaction might be, what exactly is that again? Don't worry, it's normal. Even Albert Einstein, the genius who made relativity cool, was utterly baffled by it. He famously called quantum entanglement spooky action at a distance. Yeah, spooky. Science speak for, I don't get it either. Simply put, quantum entanglement is a phenomenon where two particles become so deeply linked that measuring the state of one instantly tells you the state of the other, no matter how far apart they are. Imagine you and your best friend deciding that whenever you wear a red shirt, your friend must instantly wear blue. Now, even if your friend moves to another planet, as soon as you put on red, they'll mysteriously be in blue. No text messages, no FaceTime needed. Convenient, right? But slightly creepy. But don't panic. Quantum entanglement doesn't mean something painful happens to your atoms when you stub your toe, and somewhere far away, another you feels it too. Scientists haven't found any practical scenario involving stubbed toes, thank goodness. But entanglement has real weird consequences in the microscopic world. Photons, electrons, atoms, they're all susceptible to this entangled dance. Interestingly, entanglement isn't some ultra-rare, once-in-a-lifetime event. It happens all the time, everywhere around you, though typically at scales way too small for you to notice. In fact, your cup of tea right now probably has particles experiencing fleeting moments of quantum entanglement. And yes, scientists really debate if there's any larger scale significance to these everyday entanglements. Trust academia to argue over tea leaves. This spooky phenomenon also defies our intuition about space and time. Einstein wasn't a fan because it seemed to break his beloved speed limit, the speed of light. If measuring one particle affects another instantaneously, does that mean something traveled faster than light? Well, modern physicists assure us the universe isn't cheating. Entanglement, they insist, can't transmit actual useful information faster than light, but precisely how it all works is still debated. Yeah, quantum physics can sometimes feel like an eternal cliffhanger. But don't worry about solving quantum mysteries tonight. For now, just relax into the idea that somewhere, somehow, you might share a gentle quantum connection with another you. Strange? Absolutely. Comforting? Oddly enough, maybe a little bit. Let's imagine this together for a moment. Right now, there's another you, somewhere out there in the vast cosmos, casually sipping bubble tea and scrolling through TikTok. I know. You're probably thinking, great, another me wasting time on the internet. But who can resist cat videos and those viral dance challenges? Actually, the intriguing part isn't really about bubble tea or TikTok. It's about how quantum entanglement might connect you to another version of yourself, your quantum twin. Quantum entanglement suggests a peculiar reality. Two particles sharing an intertwined destiny, no matter how distant they become. Now, imagine scaling that concept way, way up to human size. Yes, even to the size of you. What if, on some incomprehensible quantum level, you were entangled with another you who made slightly different choices, leading a similar yet intriguingly distinct life? Sounds like science fiction, right? But here's a surprising little fact. According to the many worlds interpretation of quantum mechanics, a legit theory, by the way, every possible outcome to every event actually happens, each in its own parallel universe. That means there could literally be countless versions of you scattered across countless realities, each one subtly distinct. One might have skipped college to become a YouTube star. Another might be hiking through Patagonia right now. And yet another could have opened that little coffee shop you've always dreamed of. Of course, this theory still sparks heated debates among scientists. Many physicists absolutely love it, considering it an elegant solution to quantum weirdness. Others, however, dismiss it as nothing more than mathematical storytelling without tangible evidence. The jury is definitely still out on whether alternate yous are out there sipping bubble tea or not. Speaking of bubble tea, here's another quirky piece of trivia. Did you know quantum entanglement has actually been demonstrated using pairs of photons separated by hundreds of kilometers? In these experiments, entangled photons were generated in a lab and then sent flying in opposite directions through fiber optic cables. Amazingly, even after traveling long distances, measuring one photon instantly revealed the state of its partner, far away, as if distance meant nothing at all. Einstein might have frowned at this, but scientists just call it Tuesday afternoon. So next time you're enjoying your favorite drink, be it bubble tea or plain old coffee, consider this. Maybe, just maybe, your quantum counterpart somewhere is doing something suspiciously similar. Perhaps they chose slightly more sugar, or went decaf, or swapped tapioca for lychee jelly. Who knows? Tonight, as you drift off to sleep, imagine your quantum twin also preparing for bed. Are they also listening to Sleepcovery? Did they forget to subscribe? Let's hope they're not that forgetful. Either way, it's a gentle reminder of how astonishing and yet strangely comforting the universe's infinite possibilities can be. So, by now, you've probably heard about Schrodinger's famous cat. Poor little thing, forever stuck between life and death. But tonight, let's give that cat a break. After all, being both alive and dead simultaneously has got to be exhausting. Instead, we'll dive deeper into what Schrödinger was really getting at with his feline metaphor. And don't worry, no actual cats will be harmed in the making of tonight's story. I promise. Schrödinger came up with his infamous thought experiment to illustrate something deeply troubling about quantum mechanics, something physicists still argue over today. At its heart is a concept called quantum superposition, a fancy term meaning that tiny quantum particles like electrons, photons, or atoms can exist in multiple states at the same time. Imagine being simultaneously awake and asleep, or simultaneously hungry and full. Sounds convenient, yet completely absurd, right? That's quantum physics for you. To help people understand the absurdity, Schrödinger imagined placing a cat inside a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the Geiger counter triggers, breaking the vial and, well, let's just say things don't end well for the kitty. But quantum mechanics tells us that until someone opens the box to check, the atom is in a superposition of decayed and undecayed states. So, bizarrely, the cat would also be both alive and dead simultaneously, at least according to quantum theory. Schrödinger didn't actually believe cats could be half alive, of course. He created this absurd scenario precisely to highlight how strange quantum mechanics really is. Yet, here's an even stranger tidbit. Recent experiments have shown that not only photons and electrons, but also surprisingly large molecules, far bigger than scientists previously thought, can exhibit quantum superposition. These molecules aren't cat-sized, thankfully, but they're big enough to challenge our intuition about what can truly exist in multiple states simultaneously. And just to stir the pot a little more, physicists today still debate what superposition truly means. Does the particle really exist simultaneously in all those states, or does it simply reflect our incomplete understanding of reality? Some researchers lean towards interpretations involving hidden variables, factors we can't yet detect. Others passionately insist quantum superposition genuinely describes reality exactly as it is, maddeningly strange and counterintuitive. But honestly, this endless debate probably won't affect your daily life much. It's not like your morning toast exists in a simultaneous burnt and perfectly toasted state. Though, come to think of it, with how unreliable some toasters are, perhaps quantum superposition would explain a lot. Either way, Schrödinger's imaginary cat did its job perfectly. It forced physicists, and the rest of us, to confront the strangeness at the heart of quantum mechanics. It reminds us that beneath the predictable surface of everyday life lurks a quantum reality full of ambiguity and wonder. So, for tonight, let's quietly close Schrödinger's box and let the cat get some rest. After all, even theoretical cats deserve a peaceful night's sleep. Let's clear something up right away. Quantum entanglement is weird, spooky even, but it does not let you break the universe's strictest traffic rule, the speed of light. I know, disappointing, right? You probably imagine teleportation, instant pizza delivery across galaxies, or maybe even outrunning your emails. Sorry to burst your cosmic bubble, but physics remains annoyingly strict on this matter. Einstein famously set the universe's ultimate speed limit at 299,792,458 meters per second, the speed of light in vacuum. This isn't a guideline, it's an ironclad cosmic rule. But quantum entanglement seems to violate this rule at first glance, because measuring the state of one particle instantly defines the state of its entangled partner, no matter how far apart they are. Instantly, you ask? Like faster than light instantly? Well, yes and no. Here's the tricky part. While the correlation between entangled particles is instantaneous, no actual message or useful information is being transmitted faster than light. Think of it like this. Imagine you have a pair of gloves. If you find a right-hand glove in your suitcase, you instantly know the one left at home is the left-hand glove, no matter how far away your home is. But obviously, no magical communication happened. You just know the relationship already existed beforehand. Physicists describe this distinction carefully. Quantum entanglement provides correlation, not communication. That's a big difference. It's like watching the same Netflix series as your best friend at the exact same time in separate locations. You'll gasp or laugh simultaneously at the same scenes, but that doesn't mean you're secretly communicating faster than WhatsApp can handle. And here's a fun, slightly quirky side note. Experiments testing this bizarre phenomenon have gotten quite elaborate. Scientists have even bounced entangled photons off satellites orbiting Earth, confirming their instant connection over astonishing distances. But despite all this ingenuity, nobody's sent actual meaningful messages faster than a Wi-Fi signal yet. Sorry, Star Trek fans, your dreams of warp speed chats remain firmly in the fiction section. Interestingly, quantum physicists themselves are still debating how exactly to interpret this instant correlation. Some argue there's an underlying reality we don't yet understand, what they call hidden variables that determine particle states from the beginning. Others suggest we might need to rethink how we perceive time and space altogether. Believe me, physicists have spilled more coffee debating this than you could possibly imagine. Still, there's no denying how fascinating and, yes, mind-boggling this topic is. While quantum entanglement won't help you break speed records or deliver pizza across the galaxy, it's revolutionizing other areas. Quantum computing, quantum encryption, and quantum teleportation, though sadly still no actual teleporting people, are all exciting real-world developments emerging from this strange phenomenon. So tonight, while you're tucked comfortably under your blankets, dreaming of distant galaxies, remember that although quantum entanglement might seem like magic, it's still firmly bound by physics. It's comforting, really, knowing that some cosmic laws remain stubbornly consistent, even in a universe as bizarre and unpredictable as ours. Let's take a little stroll now into a real quantum lab, where things are simultaneously futuristic and oddly mundane. Imagine stepping into a quiet, tidy room filled with shiny machines, softly humming computers, and countless wires neatly bundled. It's like the tech version of your grandma's knitting basket. Everything seems calm and under control, but beneath the surface, this lab is where quantum particles are coaxed into their mysterious entangled dances. Now, you might picture quantum physicists as stern-faced geniuses in white lab coats, intensely scribbling equations. Sure, there's plenty of that. But quantum experiments also have their share of humorous mishaps and small dramas. Like that one time, researchers spent hours troubleshooting an experiment only to realize a loose cable had been sabotaging them the entire day. Yes, even the brightest minds occasionally forget to plug things in properly. It's comforting, actually. Science, at its core, is wonderfully human. But how exactly do researchers entangle particles? It's not as simple as introducing two electrons and saying, "Hey, you two, be friends now." Creating entangled particles typically involves lasers, special crystals, and extremely precise timing. One common method uses a crystal to split a single photon into two lower energy photons. Because these two photons originated from the same event, their properties become linked, entangled, in such a way that measuring one immediately tells you about the other, no matter how far apart they've flown. Now, this all sounds very impressive and precise, and usually it is. But quantum labs have their quirky side too. For instance, did you know researchers sometimes use quantum random number generators that rely on unpredictable quantum events to generate truly random sequences? This randomness is considered perfect, not like the supposedly random shuffle on your music playlist that mysteriously keeps repeating the same 3 songs. Yes, Spotify, we're on to you. Speaking of randomness, physicists are still debating whether quantum randomness is fundamentally real or if it simply reflects some hidden structure we haven't yet discovered. Does the universe play dice, as Einstein famously questioned? Or are there hidden rules guiding every quantum event? After decades of research, scientists haven't reached a consensus yet. It seems quantum physics loves a good mystery just as much as we do. Anyway, let's go back to our quantum lab scenario for a moment. Scientists carefully set up their delicate experiments, painstakingly adjusting lasers and mirrors with microscopic precision. After countless attempts, they're able to reliably produce entangled particles, making groundbreaking advances in quantum computing and secure quantum communication. It's both incredibly exciting and, at times, incredibly frustrating. And yet, despite the precision, mistakes still happen. There's a running joke among quantum physicists that whenever something goes wrong, the first step is always to turn it off and on again. You see, even quantum computers occasionally need a little reboot. Some things never change, no matter how advanced technology becomes. Tonight, as you drift deeper into relaxation, think of that quantum lab quietly humming along, full of brilliant minds gently coaxing nature's smallest particles into delicate dances. Remember that beneath every mind-boggling scientific discovery are ordinary humans doing their very best, sometimes succeeding spectacularly, and other times forgetting to plug in the machine. And that's actually quite comforting, isn't it? Imagine if parallel universes actually existed. And better yet, imagine there's some sort of VIP quantum passageway linking you directly to another you. Not the kind of VIP treatment that gets you free snacks or front row seats at a concert, but something arguably more fascinating, a direct connection to an alternate version of yourself, living a slightly different life somewhere beyond our universe. At first glance, this sounds purely like science fiction. But according to some interpretations of quantum mechanics, particularly the many worlds interpretation, parallel universes could be more than just intriguing plot devices. They might genuinely exist. In this view, every time a quantum event occurs, reality branches into different outcomes, creating new universes that coexist alongside ours. So yes, somewhere out there might be countless universes filled with alternate versions of you. Let's say today you debated whether to have pancakes or avocado toast for breakfast. You eventually chose pancakes because, well, pancakes? But in another universe, the other you picked avocado toast. From there, your days, and eventually your entire lives, diverge ever so slightly. Over enough time, these tiny choices could lead to surprisingly different outcomes. Maybe the pancake-loving you ends up moving to Paris and becoming a pastry chef, while avocado toast you becomes a yoga instructor in Bali. Who knows? Now, here's something even weirder to ponder. Could quantum entanglement provide a kind of subtle connection between these parallel universes? Some physicists have playfully speculated that particles entangled across vast distances might actually be entangled across universes. To be clear, this remains speculative. Scientists love to debate it, but there's absolutely zero experimental evidence right now. Still, it's a fascinating thought experiment that pushes the boundaries of what we think we know. And speaking of strange ideas, here's a quirky tidbit. Did you know that some researchers have proposed testing these parallel universe theories using quantum computers? They believe if parallel universes exist, quantum computers might tap into their vast resources to solve incredibly complex problems. Imagine borrowing computational power from an alternate universe, like temporarily stealing Wi-Fi from your neighbor, but infinitely cooler and less likely to get you in trouble. Of course, many scientists remain skeptical of these ideas, and plenty argue it's all philosophical speculation dressed up as science. Physicists still vigorously debate whether parallel universes are legitimate outcomes of quantum mechanics or just fanciful interpretations of the math. As always, reality remains stubbornly mysterious, unwilling to reveal its deepest secrets too easily. But tonight, as you sink deeper into relaxation, why not let yourself enjoy this gentle fantasy? Imagine your quantum twin out there, maybe just finishing their avocado toast, wondering if another version of them exists elsewhere, making pancakes and listening to Sleepcovery. It's oddly reassuring to think that somewhere in the infinite multiverse, all possibilities might coexist peacefully, like countless stars softly shimmering in the cosmic night. So, quantum computers sounds like something Tony Stark would casually tinker with between building suits, right? But these machines aren't just cool sci-fi props. They're real, they're growing fast, and yes, quantum entanglement plays a starring role. Let's unpack how this spooky link between particles is quietly powering the most ambitious computing revolution of our time. First, let's zoom out a little. Traditional computers, like the one you're watching this on, use bits. Each bit is either a 0 or a 1. That's the digital world in a nutshell. Tons of switches flipping on or off like microscopic light bulbs. Quantum computers, on the other hand, use qubits, which can be both 0 and 1 at the same time, thanks to quantum superposition. Think of it like flipping a coin and it lands both heads and tails, until you look. But here's where it gets wild. When you entangle qubits, they start working in tandem in a way that classical bits just can't. Measuring one qubit instantly affects the others it's entangled with. This allows quantum computers to perform massive parallel calculations that would take traditional computers longer than the age of the universe. Not exaggerating. Some quantum algorithms theoretically solve problems in seconds that would take classical computers thousands of years. Of course, before you throw your laptop out the window, let me gently say, we're not quite there yet. Quantum computers today are still babies, powerful, mysterious babies, but babies nonetheless. They struggle with stability, errors, and environmental noise. Even a sneeze, okay, an electromagnetic one, can throw them off. That's why researchers work in supercooled labs, often at temperatures colder than outer space, to keep the qubits calm and happy. Here's a fun fact. Some quantum computers use diamonds, yes, actual diamonds, to help trap and stabilize qubits. Imagine that. The world's most advanced technology depends on a rock often associated with engagement rings. Somewhere out there, a quantum physicist proposed to their partner with a diamond, and then use the same type of crystal in their experiment. Romance meets science. But wait, does this mean we'll all have quantum laptops soon? Not exactly. Right now, quantum computers are massive, expensive, and finicky. They're used for very specific tasks, like optimizing traffic flow, simulating molecules for drug design, or cracking complex encryption systems. Basically, stuff your current computer can't handle without catching fire. Figuratively, and yes, scientists are still divided about just how far quantum computers will go. Some believe we're on the brink of a new technological era. Others caution that real-world obstacles, like error correction and scaling, might limit how useful quantum systems become. So far, it's a race between hype and hardware. Tonight, as you close your eyes, picture a glowing grid of qubits, softly humming in quantum harmony, subtly entangled and calculating things we haven't even imagined yet. Somewhere in the coldest corners of a lab, our future might already be quietly unfolding, one quantum flicker at a time. Let's shift gears a bit and talk about something that sounds straight out of a spy movie: quantum communication. No, it doesn't involve secret agents in trench coats whispering into earpieces. But it does promise something every spy, and let's be honest, every internet user dreams of: completely secure messaging. Thanks to quantum entanglement, we might be entering an era where your data is not just encrypted, but fundamentally untouchable. So how does it work? Imagine this. You and your friend each have one half of an entangled photon pair. You're in New York, they're in Tokyo. Now, when you measure your photon, their photon state instantly responds, even though they're separated by thousands of miles. It's not that information travels between the two. It's that the connection was baked in from the very start. Creepy? Maybe. Cool? Definitely. This principle is what underlies quantum key distribution, QKD. Instead of sending an encryption key through traditional channels, which could be intercepted, QKD uses entangled particles to share keys in a way that any eavesdropping attempt would immediately mess things up. Like, physically mess them up. You wouldn't need fancy software to detect a hacker. The act of eavesdropping itself changes the system. It's like setting up a trap where the intruder steps on a squeaky floorboard the second they enter. In 2017, China made headlines by using a satellite named Meekis to perform quantum key distribution over 1,200 kilometers. The first time such a secure quantum link had been achieved over such a long distance. It was a landmark moment, like the first email, but much harder to explain at parties. And yet, for all its promise, quantum communication still faces major challenges. Entangled particles are finicky little things. They don't survive long when bounced around in fiber optic cables, especially over long distances. That's why scientists are now working on quantum repeaters, devices designed to extend the reach of entangled signals without destroying their delicate quantum state. It's kind of like having a chain of whisperers who are all perfectly silent, and quantum. There's also the question of scalability. Right now, quantum communication is mostly limited to research labs and a few highly secure government channels. We're still far from sending encrypted love notes or pizza orders via entangled photons. But give it time. The internet was once just a curiosity in universities, and look at us now. We're using it to watch sleepy science videos at midnight. Progress is weird like that. And of course, scientists are still arguing about the limits of quantum communication. Some believe we'll eventually create a quantum internet, a global network of entangled nodes allowing for secure, unhackable communication. Others warn that the technical barriers may prove too difficult, or that real-world applications will stay niche. Like all things quantum, it's equal parts genius and uncertainty. So tonight, as your phone buzzes one last time before bed, imagine a future where your messages are so secure, even the universe itself couldn't intercept them. That's the quiet promise of quantum communication, not just faster or fancier, but fundamentally different. It whispers, not shouts. And maybe, just maybe, that's the kind of world we want to dream of tonight. Let's talk about teleportation. Yep, that teleportation. The Star Trek, beam me up kind. The idea that you could disappear in one place and reappear in another without ever passing through the space in between. Sounds like magic, right? Well, quantum physicists have a version of it. It's called quantum teleportation, and it's very real. Just not quite what you're hoping for if you got luggage and a boarding pass in hand. Quantum teleportation doesn't involve transporting actual objects or people. Instead, it transfers the state of a quantum particle from one place to another, using entanglement and a little bit of classical communication. It's kind of like faxing someone a perfect clone of your quantum self, while destroying the original in the process. Yeah, not quite the vacation plan you had in mind. Here's how it works, simplified. Say we have two entangled particles, A and B. You hold particle A and want to teleport the state of another particle, C, to someone far away who has particle B. You do some fancy quantum measurements involving A and C, send the results through a regular message, yes, just like a text, and your friend uses that info to transform their particle B into a perfect replica of particle C's original state. Ta-da! State transferred, not the particle itself, just its identity, the soul, if you will. Dramatic, right? But don't pack your bags just yet. This type of teleportation is limited to the quantum level. It works with photons, electrons, and tiny atoms, not suitcases or sleepy YouTube viewers. Plus, remember that bit about needing to destroy the original? Yeah, probably not ideal for daily commuting. Here's a neat twist. In 2020, researchers achieved quantum teleportation between computer chips on separate silicon wafers. That's huge. It hints at future quantum networks where information zips between devices with unbreakable security and near instantaneous speed. Still not helpful for your vacation plans, but a major win for science. Oh, and did you know? Quantum teleportation has even been tested using satellites. The Chinese MISHA satellite, the same one that helped demonstrate quantum key distribution, also pulled off quantum teleportation experiments between Earth and space. Yeah, we're officially living in a sci-fi novel now. As with most quantum topics, the community is still debating what this all really means. Does quantum teleportation prove that information can leap across space in non-local ways? Or is it just a mathematical trick relying on shared histories between particles? Physicists still don't entirely agree. That's the thing about quantum mechanics. It keeps asking better questions the more we think we're close to answers. So tonight, as you lie in bed, imagine your thoughts quietly teleporting, not your body, but your curiosity, across space and possibility. Maybe someday we won't just beam data or particles, Maybe we'll beam dreams, whispers, or even late-night stories. Wouldn't that be something? Let's zoom in now. Way in. Inside your body, beneath your skin, past the cells and proteins, past the whirring engines of mitochondria, down to the quantum level. That's right. Your body might actually be playing host to tiny quantum phenomena. Yep, you're not just made of atoms. You're possibly entangled with them too. No pressure. For a long time, scientists believed quantum effects like entanglement and superposition couldn't survive in warm, wet, messy environments. Like, well, you. The human body seemed far too chaotic for fragile quantum states to hold up. But in recent years, that assumption has been challenged by some pretty weird findings. Take photosynthesis, for instance. Plants are pros at converting sunlight into energy, and some studies suggest that quantum coherence, basically a kind of wave-like efficiency, helps them do it. Yes, plants might be quantum-savvy little sun-powered machines. Next time you talk to your houseplant, remember, it might understand more physics than you think. And then there's avian navigation. Some migratory birds are believed to use quantum entanglement to sense Earth's magnetic field and migrate across continents. How? There's a protein in their eyes called cryptochrome that might allow quantum reactions to occur, helping them literally see the magnetic field. Yes, birds may be doing quantum physics every time they flap their wings south for winter. No lab coat required. So, if birds and plants can do it, what about humans? That's where things get both intriguing and controversial. Some studies suggest that quantum processes may play a role in your brain, especially in how neurons fire and how you form memories. There's even a hypothesis called OR, Orchestrated Objective Reduction, that suggests consciousness itself might involve quantum effects. But don't get too excited. Many neuroscientists are still deeply skeptical, and the debate is far from settled. Still, it's worth noting that your body is full of entangled particles, whether or not they're doing anything spooky. Every atom in you came from stars, from supernovae, from the birth of galaxies. And some of those atoms might still be linked, statistically, not spiritually, to others scattered across the cosmos. It's kind of poetic if you think about it. There's even a hypothesis that DNA mutations might occasionally be influenced by quantum tunneling, a process where particles skip over barriers they shouldn't be able to cross. That's right. Your family's weird nose or your ability to wiggle your ears might, just maybe, have quantum roots. That's one way to explain your dad's dance moves anyway. As usual, scientists are still debating how deep these quantum effects go in biology. Some think they're fundamental. Others argue it's just coincidence or over-interpretation. But even in disagreement, one thing is clear. The boundary between the quantum world and the biological one isn't as sharp as we once thought. So tonight, as you breathe quietly and drift off to sleep, remember, somewhere inside you, little particles might be dancing to quantum rhythms, echoing the movements of stars and leaves and wings. You're not just stardust, you're quantum dust, too. All right, let's step back for a moment. After all this talk of quantum teleportation and biological entanglement, one might wonder, why does the universe even work this way? I mean, seriously, who designed this rule book? And did they have a twisted sense of humor? Classical physics, the kind that explains falling apples and orbiting planets, is clean and intuitive. You push something, it moves. You heat something, it gets hot. But quantum physics, oh no. It's like the universe cracked open a can of abstract art and spilled it into reality. Suddenly, particles don't just exist. They maybe exist in multiple places at once. They don't just spin, they sort of might spin in two directions simultaneously. This strangeness has led many physicists to ask, why does the universe follow quantum rules in the first place? Is there something deeper beneath even quantum physics that explains it all? Or are we simply stuck with this reality because that's what exists? Here's where things get philosophical. Some scientists, especially those in the field of quantum foundations, think there may be a more fundamental theory waiting to be discovered. Something that would make quantum mechanics look like just one chapter in a much bigger book. Others propose that quantum weirdness isn't weird at all. We just aren't evolved enough to intuitively grasp it. Then there's the anthropic principle. It suggests that maybe the universe has the laws it has, because if it didn't, we wouldn't be here to ask the question. In other words, only in a universe with just the right kind of quantum weirdness could observers like us exist. If everything made more sense, maybe we wouldn't be around to notice. Sound like a cosmic loophole? Yeah, a bit. But it's the kind of thinking that pops up when your best theories stop giving you clear answers. There's also the idea that mathematics itself might be the true language of the universe. Quantum mechanics, as weird as it seems, makes stunningly accurate predictions. So accurate that many physicists trust the math more than their own instincts. Maybe the universe doesn't care whether we understand it. It just is. And math is how it speaks. Here's a quirky tidbit. Richard Feynman, one of the greatest quantum physicists ever, once said, "I think I can safely say that nobody understands quantum mechanics." And this was the guy teaching it. If that doesn't make you feel better about being confused, nothing will. So, why did the universe choose to run on quantum rules? We don't know. Maybe it's the only way to make something from nothing. Maybe it's the result of mathematical necessity. Maybe it just wanted to keep things interesting. After all, would you rather live in a clockwork universe where everything is predetermined, or one where particles can surprise you, teleport across space, and tangle up like cosmic dancers? Tonight, as you lie back and let the world blur, remember, the universe doesn't always make sense, but it doesn't have to. Sometimes not knowing is the most beautiful part of all. Hey, so let's take a detour into something softer, warmer, and slightly cheesier. Love. Don't roll your eyes just yet. Tonight, we're talking about quantum love, or at least how quantum entanglement has somehow been roped into the world of dating advice, soulmates, and internet memes. So here's the scene. Two particles become entangled. No matter how far apart they drift, across galaxies, coffee shops, or messy breakups, their states remain mysteriously linked. Sounds romantic, right? Somehow, this cold technical phenomenon got adopted by poets and Pinterest boards. You'll hear things like, "We're entangled at the quantum level," or "No matter where you go, I feel you." It's the new zodiac sign, just with more physics and less Mercury retrograde. Let's clarify something first. Actual quantum entanglement doesn't apply to your emotions. You and your ex are not connected through subatomic vibes. No matter how deeply you felt something, it's not because your electrons are whispering across the void. Sorry. That said, the metaphor isn't totally useless. Entanglement is about two entities becoming linked through shared history. Once connected, changing one instantly reflects on the other. Sound familiar? That's basically every intense human relationship ever. There's even a term in physics, monogamous entanglement. It means if two particles are fully entangled, they can't be equally entangled with a third. So yeah, quantum physics supports exclusive relationships. Sorry, polycules. Now, does this mean you should base your love life on physics? Please don't. Imagine telling someone, "Sorry, babe, our wave functions aren't compatible." That's not cute. It's confusing. But here's what is beautiful. Entanglement tells us that what you do matters, even across distance. That your actions, your presence, your shared memories, they leave a trace. Maybe not in the literal physics sense, but in that quiet, emotional space where you once existed together. And if you're someone who's lost someone, through time, distance, or just drifting apart, it's okay to believe a little in the poetry of entanglement. Not as science, but as a soft reminder that some connections don't just vanish. Just don't try to detect them with a particle collider, all right? Let's take a slightly weirder turn. You know how sometimes people say things like quantum healing or manifest your dream life using quantum vibrations? Yeah, we're stepping into quantum mysticism now, the blurry zone where science ends and wishful thinking begins. It's a place filled with crystal shops, vague spiritual blogs, and Instagram accounts with galaxy backgrounds and quotes like, "You are the universe experiencing itself." Spoiler, that's not quantum physics. That's just poetic vibes, with a dash of Photoshop. Let's be fair, quantum mechanics is weird. It's non-intuitive, non-deterministic, and kind of magical feeling if you're not used to the math. So it's no wonder people started saying, hey, maybe it explains the soul, or maybe our thoughts change reality. Here's the deal. Quantum theory does describe particles behaving probabilistically, and the observer does seem to affect the system in certain experiments. But that doesn't mean thinking hard enough will get you a Tesla. Sorry, vision board enthusiasts. Some people take the uncertainty principle and turn it into a self-help slogan. Nothing is fixed. You can be anything. And while that's motivational, Heisenberg probably didn't mean you should quit your job to become a DJ because electrons are free. There's also this trend of linking quantum fields to consciousness. Maybe our minds are entangled, they say, or consciousness collapses the wave function. Sounds deep, but we don't know yet. Really? Even physicists argue about what consciousness actually is, and whether it has anything to do with quantum mechanics at all. In short, it's a mess. A sparkly, slightly suspicious mess that sells a lot of books and guided meditations. There are whole seminars charging hundreds of dollars to align your chakras through quantum frequency. Does this mean you should roll your eyes at everything non-scientific? Nope. We all need metaphor and meaning. And if someone finds comfort in quantum poetry, let them vibe. Just don't mix it up with actual physics papers, okay? Science is humble. It's okay with not knowing everything. And right now, the connection between your thoughts and quantum fields, still unconfirmed, still beautiful, in a speculative kind of way. So yes, meditate, journal, align your vibes. Just don't call it entanglement, unless you're working with a particle accelerator. So, let's say one day, you woke up and somehow felt different, like something had quietly snapped. Not in a dramatic, your life is over way, but more like a subtle shift, like the TV channel of reality flipped for half a second. You feel it when you walk past a mirror. Your reflection lags just a bit. You blink. Did it just? Nope, it's fine. Must be sleep. But the weirdness builds. The way your cat looks at you like you're not quite the same. The toast burns at exactly the same spot 3 mornings in a row. Your phone unlocks with your face, but slower. Could it be? Your quantum entanglement got cut? Yes, that thing. That invisible thread that may or may not have been connecting you to your entangled twin in a faraway corner of the universe. According to some interpretations of quantum mechanics, when 2 particles are entangled, they remain connected no matter how far apart they are. But this connection can be broken by interaction, by measurement, or just by existing in a messy, noisy universe. So if you were entangled with another version of you and the thread snapped, what changes? Would you feel more alone? More free? Would déjà vu stop happening? The truth is, we don't know. Physicists debate this. Some say it's purely mathematical. Others suspect there's more to it. That entanglement isn't just a cold data link, but part of a hidden architecture of the universe. Still, here's a thought experiment. If the entanglement did break, would that mean the you on the other side of the connection is now independent too? Maybe they're feeling the same echo. Maybe they've started dreaming about you. And what if, just what if, you two now drift closer in some strange way, no longer synchronized, but curious about each other's fate? Maybe one day you'll cross paths. At a cafe, in a dream, on a late-night YouTube comment thread. People have always longed for connection. Quantum physics just gave it a fancy new metaphor. Maybe you're not really cut off. Maybe it just evolved. A broken entanglement isn't an ending. It's just the start of a different kind of uncertainty. You lie back, eyes half closed, still lingering in that quiet thought. What if quantum entanglement isn't just a physics thing? What if it's also a poetic one? In the quantum world, certainty is a luxury. Particles don't just be, they may be. They spin left and right, exist and unexist, until someone watches, until the universe shrugs and picks a side. You, right now, are kind of like that. Not because you're tiny, though you do look cozy in that blanket, but because you live in a world full of unresolved probabilities. What path will you take tomorrow? What version of you is already out there making a different choice? The theories say you won't ever meet, but let's be honest. Physics doesn't always get a final word. There's wiggle room, there's quantum foam, there's hope in the weird. Somewhere between spooky action and soft dreams, you exist, unique and maybe mirrored. Somewhere, someone may be dreaming of you too, maybe even right now. So you breathe, not to solve anything, but to float gently with it. You're not lost in the universe, you are of it, tangled and untangled again and again in ways we haven't fully understood yet. And maybe that's okay. And now, feel the breath deepen like waves slowing as they touch the shore. You've walked through entangled space, strange mirrors and quiet maybes, but now your thoughts can fold like soft origami. No need to figure everything out. Tomorrow can wait. And if some far-off version of you is still wandering, that's okay. You've earned this stillness. You're exactly where you need to be, wrapped in gravity, breath, and maybe a touch of starlight. So rest. You are not alone. You are never truly separate. You are gently entangled.